point is very important. On this, our whole concept of stack is based. That concept is operations or functions in stack. Okay. If the concept of this is clear, the coding for it will also be clear for you. You will understand the code written if you know the concept. So let's try to understand the concept one by one. The very first function that we have is push. So yes, the very first operation that we are going to see is push operation. When you say push, you are actually inserting an element, putting the element into the stack element. Now suppose this is my stack. The maximum stack size is 5. That means I've statically trying to implement this stack where the maximum size is 5 and the memory would be allocated. Okay, now I want to insert the element, so I am going to use the function push. There will be code written inside it that is going to help me to put the elements inside the stack. So suppose my element is 10. I'm asking user to insert the element and the element is 10. Now when I want to insert, I'm going to use this function. So there will be code written inside it. That code is going to help me to insert this element. So we have a top that is going to be associated with a stack. Suppose I name this particular stack as stack. The name of this stack is stack. Okay, I'm using this variable because the same variable is used in my programming. My top will be always -1 when there are no elements inside my stack. When I've just created a stack and there are no elements inside my stack, that means my stack is empty. My top will always be pointing to -1. Can you see that? Now when I'm trying to perform push function, I need to point here first. Then only I can insert this element. So what I'm going to do, I'm going to use this top to point to this location. Now for example, my top is pointing here, right? Something which is below 0. Now I'll increment my top. Top is equal to top plus 1. Right? So top is what? It was -1. You add 1, it will become what? 0. -1 plus 1. It will be 0. That is, top value is now 0. And when I point here, when my top is pointing here now, here I am going to insert this element. Now how will I insert the element? Just like array, you do A0, A1, right? A0, A1 to associate to that particular location of that array. Similarly for stack, this is the name of my stack. What am I going to say? Stack of top. So wherever is my top, I'm not going to say stack of 0, right? I would not know where my top is pointing. So wherever is my top, I would say stack of top. Stack is the name of my stack. This can be anything. This name can be anything. Okay, you are naming the stack. So I say stack of top equal to n. Similarly, I want to insert new element. Okay, m equal to 20. I'm taking it from user. 20 when I want to insert. Now my top is pointing here. I need to increment my top first. Top is equal to top plus 1. What is my top right now? It is 0. So 0 plus 1. That is what? 1. So where is my top now? 1. And what is my next line? Stack of top equal to m. So when I say stack of top equal to m, that means my top is now pointing here. And in this particular, for this stack, wherever the stack is pointing, the top is pointing for that stack, there I have to insert this element, that is 20. Increment top first, then insert the element. Only 2 things to do when you are trying to perform push. Now there is one more function which is associated with push, that is full. Now if I have this stack, elements are already filled till the top, maximum size is 5. Is there space inside my stack? Visually when I'm seeing, I can see that there is no space. I cannot insert any element because maximum size is 5 and already an element is inserted till the last point. So for that, I need to always check the condition is full. So this is your last element. So as we already know, this is the last element. My top would be pointing to this. Now according to push condition, I'll increment my top. Now I need to check whether this position is greater than equal to this. So your top is greater than equal to max minus 1, you can see. Max is 5, max minus 1 is 4. Is your top greater than 4? In this case, yes. Here I need to check this condition using if statement. That my top, is it greater than max minus 1? If it is greater, please stop. So this is the concept, push and is full. The next function that we have is pop. Now what do we do in pop function? We try to remove the elements. Concept is LIFO. LIFO stands for last in, first out. The last element to enter will be the first element to come out. So I already know that I have inserted element. My top will be pointing here. Push function, remember, top will be minus 1 when the stack is empty. Then you will increment the top, insert the element till the maximum size. After that, you will not be able to insert the elements. So now my top was pointing here. In order to delete element, what am I going to do? Top minus minus or top minus 1, anything. So when I do top minus minus, my top for now is what? It's top of 4. It's pointing to 4th position, right? Now when I do minus minus, that means what? Top of 3. One step down. So this is my top. My top is decremented. Automatically this element is deleted. So in pop, there's only one line that you have to mention is top minus minus or top minus 1. If you are using concept of stack, your last element is only the one that is going to be deleted. So when you do top minus minus, your top will be pointing downwards. The element that it was pointing to will be deleted. Now with pop, there is one more function, that is empty. What is this is empty function? Whenever I am deleting the elements, I have to check whether my stack is empty, because if my stack is empty, there is no point of deleting elements. My top would be where? Suppose this was the last element, top was pointing here. Again I do top minus minus, top will become minus 1. If my stack is empty, there is no need to pop an element. With that, we have peek function. Now peek function talks about wherever your top is pointing to, it will display that element to you. Now suppose this was my stack, 10, 20, 30. Okay. Currently, this is my stack. My top will be pointing here. Okay. Top is pointing here. Now when I say peek function, what is peek function going to do? It will return the value where your top is currently pointing. And the last function is display. Display function talks about traversing through your stack and displaying all the elements in the stack. Now when you display elements also, you are supposed to display in this fashion, because we perform last in, first out. So my elements would be read in this manner only. First it will be 30, then it would be 20, and then it would be 10. Now for this particular topic, as I said, very important concept and very easy concept in data structure. If you know the concepts well, if you know these pointers well, you can attempt the question very well. And if these concepts are clear, that is when you will understand these functions when you programmatically write it. So you can refer those videos to understand programs for this now. How to write the functions. Videos made for these functions separately. I would want you all to go through those videos so that you understand those functions better and implement in programming. If there are any doubts, any questions, you can just put in the comment section so that I understand it better as to what are the things that are to be included more. Okay, don't jump directly to functions. First get your concepts clear and then you can move to your functions.